Okay, so in this video, very briefly, this is our second video for day 9. Um, I'm going to talk about quadratic vertices. There's two ways to acquire them. So one way is how we've been looking at this. So if we've got a quadratic um, function graphed out like so, well, we know the vertex. Whoops, we know the vertex happens at h by k, and h and k is referring, of course, to vertex form when we have a times x minus h all squared plus k, right? So that's where our h and k come from. The h value is the x, and the k value is the y of our vertex, right? Now, there's another way to calculate this. We can also say that the vertex happens not only at h by k, but we can also calculate it by doing a simple little formula. The x value comes from negative b divided by 2 times a, and our y value comes from f of that x value, negative b over 2a. Okay, so we'll look at two examples of getting this, right? So first, let's look at f of x here in green, right? So I'm going to do it the old fashioned way by completing the square real quick, and then I'm going to also do it by using this little formula that we have here. And I need to close the other parentheses because that's going to bother me. Anyway, so I'm going to factor out a negative 3. That, of course, leaves me with x squared plus 2x minus 7, still sitting out there waiting to be used. Okay, and now I'm going to complete the square. So negative 3 times x plus 1, all squared, minus 1. Minus 7 is still sitting out there. Redistribute the 3 back inside. Okay, and we have, this is our vertex form. Okay, so we know now that our vertex happens, and let me readjust our picture here to kind of fit what we've got. We know that our vertex is going to happen at negative 1. We'll say negative 1 is here, by negative 4. We'll say negative 4 is over here. Whoops. Okay, so this is where our vertex would be. And of course, we know that we're opening downwards because we have a negative a value. Okay, so now let's use our little formula here to see if we get the exact same vertex, right? So negative b, negative 6, right? So that's negative b, negative 6 over 2 times a. Okay, so then we're going to end up with 6 over negative 6, which is negative 1. Well, hey, that worked out. Negative 1. Okay, and then we're going to do f of negative b over 2a, or f of negative 1, which is going to be negative 3 times negative 1 squared minus 6 times negative 1 minus 7. Right, and all I'm doing is plugging into this guy here. Okay, so that's going to give me negative 3 plus 6 minus 7, right? And that's going to put me at uh, negative 4. Negative 3 plus 6 is negative 3, or my bad, positive 3. And positive 3 minus 7 is negative 4. And here we have it again, it checks out. Okay, so that's one way to have found the vertex. Okay, and that actually was quite a bit quicker than just completing the square and doing all that. I don't know, it's a matter of preference, right? Okay, so let's see another one. So while I'm erasing, I just want to say I can't stress enough, this is all a matter of preference. Sometimes it's going to be more convenient to simply use our little formula to calculate the vertex, negative b over 2a, and then f of that, right? And sometimes it'll be more convenient, depending on the context of the problem, it'll be more convenient to simply complete the square. Okay, so we're only looking for the vertex, right? That's all we're being asked to find. We're not necessarily being asked to graph anything. Okay, so our vertex is going to happen at negative b over 2 times a, right? So that would be positive 8 over 8, so at positive 1 this time. Okay, and then our y value of our vertex is going to happen at g of negative b over 2a, or in this case, g of 1. So that's just going to be 4 times 1 squared minus 8 times 1 plus 6. That's just going to be 4 minus 8 plus 6. Okay, and that's going to give us negative 2. So our vertex for this function happens at 1 by negative 2. That would be our h by k, right? And we know our vertex would be at 1 by negative 2. Okay, so one last example we're going to look at, and this is kind of a ridiculous, real world, quote unquote, uh, example. So Ash is a bully trying to see how far he can kick uh, Josie's ridiculously heavy backpack away from her. It's this kicking power is demonstrated by this function right here. Okay, so where h, the height of Josie's backpack in the air, and it's a function of p, or position in yards. Okay, so our height depends on the position that the backpack is in. It doesn't depend on time, right? So we've got two functions of space. Pretty unique little function here that I just kind of came up with. But anyway, so real fast, let's find the vertex. Okay, so to find the vertex, we would need to do negative b over 2 times a. Okay, so that would be negative 40 over negative 20, which is going to give us positive 2. So our vertex happens at 2. Okay, and again, this is 2 yards because we're talking about position in yards. Okay, and I assume the height also is in yards. Didn't really specify that there. But anyway, so now we just need to calculate f of 2. So at what height does this all happen, right? So we'll say this is f of 2, right? But we don't know, and I shouldn't even say f of 2. I should say h of 2. What's the matter with me? That's height at position 2 of 2 yards, right? So all I'm going to do is plug in a 2. So h of 2 is equal to negative 10 times 2 squared plus 40 times 2 minus 10. Okay, so this would give me negative 40 plus 80 minus 10. That would give me, let's see, 40 minus 10 is 30. So h of 2 would be 30 yards. So our vertex is 2 by 30. And we found that out without doing anything special, right? Okay, so we can already answer number 2 here. How high in the air did Josie's backpack go? Well, it went 30 yards. Oops, 30 yards. Okay, and how far has Ash kicked Josie's backpack? Well, we need to figure out um, the distance from here over to here, right? We know the function's going to open downwards because we have a negative a term. Okay, but all the same, we need to do the math, right? So that means we need to calculate the x-intercepts. Okay, so that said, we know the y-intercept is negative 10, so I can go ahead and say negative 10 is down here, right? And I can kind of get an idea where we're going. Okay, but I don't know this x-intercept, and if I make it symmetrical, I don't know this x-intercept. Okay, so we can easily figure that out by just setting this equal to 0 equals negative 10 p squared plus 40 p minus 10. I can divide this entire equation by, by negative 10, we'll say. So again, I can say 0 equals just p squared minus 4p plus 1. right? And off the top of my head, I cannot factor this, but I could complete the square and solve this really easy. Okay, so real fast, I'm going to say that this becomes p minus 2 all squared minus 4 plus 1, right? And combine like terms, p minus 2 all squared minus 3 equals 0. Then I just solve that equation. Okay, so that just becomes, so I'm going to add 3, take the square root. So that just becomes p is equal to 2 plus or minus the square root of 3. Okay, so let's see what that comes out to. 2 plus the square, oops, 2 plus the square root of 3. That's about 3.73. 3.73 yards. That's our first x-intercept there, and then 2 minus the square root of 3. That would be at about 2.268. So we're going to just say 0.27. So about 0.27 yards. Okay, so if we just subtract the difference, so that minus that, we end up with about 3.46 yards from here to here, right? So the distance covered by the backpack as we sail through the air, right? The distance covered would be about 3.46 yards. To answer number one, how far did Ash's punt send Josie's backpack? Okay, so that does it for this video. Like I always say at the end of these, let me know if you need anything via email or come and see me. Goodbye.